Lastly, we looked at the vector equation of a line, right? Let's just run over that, and then we want to test something called what? Somebody, I remember to just Q, right? Qness, right? Want to check and see if lines are skewed or not. All right. Right. Let's just go over where we stopped last week. Right. So last day we looked at the vector equation of a line. Right. What you're seeing there should be to the vector equation of a line, right? We looked at proving it, and we looked at taking this is the vector equation of the line, right, Shivish? And we went from the vector equation of the line, we went into the parametric equation of the line, right? How we did that, we made x, y, and z the subject of the formula. After the parametric, what was the next version? The Cartesian, right? And to get the Cartesian form, what we did? We made we made lambda the subject in each one, and we equate them. All right. So you make lambda the subject in each one, and then equate it. All right. So those are the three forms: Cartesian here with no lambda, parametric with x, y, and z in terms of lambda, and your vector equation of the form with what's A and B again? A is the what? R is the random, R is the equation, A is the point on the line, and P is the direction vector, right? And B is the direction vector. All right, nice. Let's do one quickly. Do my favor. I think I can give it over already. I sent it back that time. I sent it. No, I said nothing. Nothing I said. Write this here. Write this equation on the line, and I want you to go from here back to all the others. What is called this form again? Cartesian. So take the Cartesian, get the parametric, then get the vector. Try that fast. I find the Cartesian, find the parametric, right? You could use constant as lambda, right? And get the next one. Try that fast. Take your time, right? Each form. Take your time. Absolutely. All right, so you would recognize that you can make lambda equal to everything, right? And then make x the subject. You all got that for the Cartesian? Sorry, for the parametric? Yeah. Right, so you let lambda equal to everything. You let lambda, sorry. Oh, crap, what is happening there, right? Oh, so you let lambda equal to everything, then you make x the subject, y the subject, and z the subject, right? Right, sorry. So you make lambda the subject in each case, and then you solve for x, solve for y, solve for z, right? And this is your parametric form. And then to go to vector form, once you write it neatly, this is your r, this is your a, and this is your b. Right? So you'll end up with, if you write it neatly, right? Minus 1, 2, 1. That's the A. And then you have plus 3 lambda minus 5 plus 4. That is your B. Okay, so you could write R plus minus 1, 2, 1 plus lambda by 3 minus 5. Right? So those are your different forms. I just wanted to remind you what the different forms, right? Nice. So what do we do next? The next thing that we need to learn to do, oh, copy down in case I didn't get it. The next thing we need to be able to do is we need to know if vectors are parallel. How do you know if vectors are parallel? They are what? Right, they are multiples of each other. Right, if they intersect, it means that when you solve them, you should get a solution, common solution. And if they don't intersect or they are not parallel, they are said to be skewed. So we're going to take a look at something called skewness now. All right. Before we do skewness, how do we look at how do we know parallel lines? Right. Just make a note of that. If you have two lines, line 1 and line 2, to determine if they're parallel, you have to compare their direction vectors. Okay. So you're comparing B and B. If they are multiples of each other, then they are parallel. All right. Just make a note that you have to compare the direction vectors. Right. That's one thing that we tend to forget. All right, that's to show parallel. And please don't focus on the points, focus on the direction vectors. One is lambda, one's supposed to be mu here. Oh yeah, B is equal to mu D here. Right, so B is equal to mu D. Have we done fast?
Watch down what touch.
All right. So how do we show vectors are parallel? We look at the direction vectors, right? Right. So all you have to do is remember which ones to look at. So take a look at L1, L2, and L3. Which ones they are parallel? So I kind of cross out. If you look at the note, I kind of cross out some parts of it, right? I kind of cross out this curve. The way you're looking at that. I want you looking at direction vectors. So which of those direction vectors are L1, line 1, line 2, or line 3? Line 1 and right? Yeah, because if you multiply this by 2, you will get this vector, right? If you multiply this by 4, the numbers working out except for 2. So it means that line 1 and line 2 are parallel. Alright? Alright. So our focus really is to determine if vectors intersect or not. Right? And watch this here. Right? This is the best I could do. If lines are parallel, if vectors are equation of a line are parallel, they look like the first diagram. If they intersect, they look like the second diagram. If they are skewed, means that they are not parallel and they don't intersect. So they look like the third diagram. Two totally different planes. Alright? That's okay? So you're focusing in 3 dimensions, right? Those lines will never meet. They're looking like they might intersect, but they are totally different planes. Right? And a line is something 2-dimensional. So that is not going to meet at all. Alright? Right. So we're looking at something called skewness, right? How do we show skewness? Well, in order for us to show skewness, we have to show that the vectors are not parallel and they don't intersect. All right. So I want to show you now how to determine if vectors intersect. All right. So just do my favor now. Just copy down QNS, and then I want to give you do a couple examples with you. All right, just make a little sketch here and tell me what you got. All right, so I'm going to show you now how to show vectors, how to determine if they intersect. Oh yeah, I remember this is the most of it. For the example. All right, anybody write pencil? All right, so how do we show intersection, right? So I want you to have an idea of what we're trying to achieve, right? So if I give you a plane, right, and you want to determine if line 1 and line 2 intersect, then obviously they will be parallel, right? And they will have this point here in common, right? So they have a point. So this point, whatever the point is, let's call the point X, Y, Z. That point should be common to both L1 and L2. All right? So what we're going to attempt to do is to solve the equation and see if both L1 and L2 have this point in common. That's okay? Right? Basically, what we're doing, we're going to get two equations solved simultaneously. Right? And then plug it back in and say the third point is the same. So we're going to take X and Y for both of them, solve it simultaneously, and then check for Z. Okay? So let's take an example, see if it makes sense, right? Let me get an example here. All right, so let's try an example here. right? So I'll give you line one. You'll see okay here online. I was saying here, right? Minus 215. Minus 31 minus 5. L2. Right? Minus 215. Right? Minus 31 minus 5. Minus 3 211. And 5 minus 1 4. All right, so I'm going to give you an idea of the steps that we're going to take and how we're going to go about this, right? So the first step, we're going to write the lines. We're going to take L1 and L2, and we're going to put it in the easiest form to read off. We're going to put it in the parametric form, right? We're going to put it in the parametric form. After we do that, we are going to solve X and Y simultaneously to get, we're going to solve X and Y simultaneously to get these two things here, to get lambda and mu, to get lambda and mu. And then the third step, we're going to substitute lambda and mu in Z, right? For both of them. Right? We're going to substitute lambda in Z to determine if they intersect. Right? So these are the three steps that we're going to take. What are the three steps again, Shivish? What are the three steps again? Huh? Oh Lord, boy, the three steps here. Take L1 and L2, put it in parametric form. Then second step is to solve X and Y simultaneously to get lambda and mu. Step 3, lambda and mu, put it in Z. All right? So watch here. All right, you can just take it in there online and you'll watch steps, right? So the first thing I will do if I'm doing a question like this is, Kira, I'll watch these two and I will check and see if they're parallel. Are they parallel? I can't multiply this by anything to get this. So they're not parallel, right? So I'm going to check and see if I can follow those steps to see if they intersect, right? Copy it, I'm going to make sure they're ready. If they're not ready yet. said she go, don't you don't go to Ready? Should we write any slow? Or you have to boy, I want to start. Begin now, one right steps. Right. So step number one for L1, I'm going to put L1 into parametric form. So R is XYZ. So X is minus 2 minus 3 lambda. X is minus 2 minus 3 lambda. Next step, Y. Y is equal to 1 plus 1 lambda. And Z is what? Z is 5 minus 5 lambda. Now for L2, are you okay with that? Should be L2. What is X? Minus 3 as mu. Yeah. Right? So X is equal to minus 3 plus 5 mu. Then Y is equal to 2 minus mu. And Z is equal to 11 plus 4 mu. Right. Now, next step. We have to solve simultaneously. If these 2 points intersect, then the X values will be equal, Y values will be equal, Z values will be equal. All right? So all I'm going to do is I just go in and I'm going to equate. So I'm going to equate here and here. So minus 2 minus 3 lambda is minus 3 plus 5 mu. Right? And we can rearrange and work it out. What you'll get. Bring it across, you'll get 1 minus 3 lambda is equal to 5 mu. We might get mu the subject. All right, let's check the next one out. Right, so leaving it like this. Bring it across here, I'll get 1 minus 3. Next, I'm going to equate the y's now. Right? I'm going to equate the y's. So 1 plus lambda is equal to 2 minus mu. So this is much easier to make lambda the subject, right? So lambda is equal to carry across the 1, and you'll get 1 minus mu. That's okay? So I equate them, X, I equate the Y, I solve for equation 1, equation 2. I'm going to put this in this. Right? So I'm going to substitute equation 2 in equation 1. So I'll end up with putting lambda here. So I'll get 1 plus 1 minus mu is 2 minus mu. What has happened there? Oh. Yeah. I write it wrong. I get frightened every. What I make up a bad one. Yeah, what you want. So that's 1 minus 3 by 1 minus mu is equal to 5 mu. So 1 minus 3 plus 3 mu is 5 mu. Bring all the mu's on this side, and you'll get 2 mu. So mu is equal to minus 1. Plug in minus 1 there, and you'll get lambda. Lambda is 2. Right, Shivish? Keep watching here. Lambda is 2. What's the last step? We found lambda, we found mu. Substitute them and see where you get for Z. So for L1, Z is what? Z is 5 minus 5 by lambda. So I got 5 minus 10, which is minus 5. And for L2, Z is equal to 11 plus 4 by minus 1. So that's give you one left parallel. Hold on, huh? Did I write down the correct thing right? Oh, all right, sit down bad. It's supposed to be -5. That won't affect anything, right? -5 minus 11. Right? -5 minus 11. Right? -5 minus 11. So this would have been -15, and this would have been -15. If the value is not the same, it means it's not consistent and they don't intersect. Right? From my first example was supposed to intersect. So therefore, L1 and L2 intersect. Right? And we can be more specific and tell them where it intersects. The Z value is -15. The X value is what? We could put lambda in here or put mu in here. Put lambda here now. You'll get -2 minus 6 is -8. If you put mu in here, you'll get -a2. And then put it in here. 1 plus 2 is 3. Check it here again. 2 minus -1 is 3. So that's the point. All right? Right? So online, in case I get lost, right? I made a mistake with the signs in the early. It's -5 minus 11. Right? When you solve for lambda and mu, plug it back into Z. If it get the same values for both lines, it means that it is consistent and they intersect. If the values are not the same, it means they do not intersect and they are skewed. Right? Rana? Where you get lost? How I get this? Yeah. You follow how I get this, right? I plug in lambda and I plug in mu. So the point where they intersect, you can take mu and put it in here, and you'll get the point. Or you can take lambda and put it in here, and you'll get the point. Same, have to get the same thing, eh? Because remember, they both have that point in common, right? All right, any questions online? Amanda, Emily, any questions? Francis? Right, so we're following these three basic steps here, right? We're following those three basic steps. All right, so we gotta try one now, right? All right, but okay there. Khaled, Safir. All right, so remember, what are the steps to show skewed? Check and see if they parallel. Check and see if they intersect. Otherwise, they'll be skewed, right? If they do intersect. Try this one here. I'm just gonna help out a little bit to put the forms, right? Determine if the points intersect. Are they parallel by chance? Chivish? Are they parallel? Why is it up? Sure. Huh? Okay. Right, so they're not parallel. I just I do you a little favor. I put the parametric form here one time, right? Look at this. And if they intersect, find the point of intersection. All right, online it would be really nice if we can send an answer, right? So here, send an answer, right? Right, Emily, well, not you, Amanda, you good. Asia, Asia, not you. Jogging there. Where to be Sean, Ariana, you're a good idea. Huh? That's a good idea. Right? If they intersect, find the point of intersection. right? If they intersect, steady point of intersection, right? Intersect or not? Yeah. Intersect? Or you got a point? Yeah. Okay, so let's see now. So let's put it together, right? So let's start with L1. For L1, x is equal to minus 5 plus 6 lambda, minus 5 plus 6 lambda. Y 2, sorry, 2 minus 3 lambda. And z is minus 3 plus 9 lambda. Do the same thing for L2 one time. X is equal to minus 5 minus 2 mu. Y is equal to minus 4 plus 3 mu. And z is equal to 3 minus 5 mu. Right? Z is equal to 3 minus 5 mu. Right? Then we do a little equating. It doesn't really matter which one you choose. Huh? You can equate these two and then check for consistency here. Right? It don't matter. Once you get lambda on you can put it in here if you want. Right? But I will equate these two here. So I'll get minus 5 plus 6 lambda is equal to minus 5 minus 2 mu. Carry it across again, 0. So 6 lambda is minus 2 mu, or we're getting mu to be minus 3 lambda. Look at that. Yep. And then we're going to equate the y's. So that'll be 2 minus 3 lambda is equal to minus 4 plus 3 mu. Right? Bring it across here, you'll get minus 4 become plus 4. 4 plus 2 is 6. Minus 3 lambda is 3 mu. Right? If you want, you can just divide everything by 3. So that'll be 2 minus lambda is mu. Okay? Then we can equate them. Right? We can substitute 1 and 2. So you'll end up with 2 minus lambda is equal to mu. Mu is minus 3 lambda. Right? Right? When you bring it across, you'll get minus 2. So I got lambda to be minus 1. Yeah, Shibish? Lambda is minus 1. So if lambda is minus 1, plug minus 1 in there, and you'll get mu as 3. Yeah. So now we're going on checking L1. So z is equal to what? Z is equal to minus 3 plus 9. Minus 3 plus 9 by lambda. Right? Lambda was minus 1. So that's minus 12. We're going on checking 2. 2 would be here. So that'll be 3 minus 5 by 3. Mu is 3, right? Minus 15. 3 minus 15 is minus 12. Okay? So therefore, right, we know z. So therefore they intersect. right? Where they intersect, we're going to determine now z is minus 12, right? So let's find x. X is minus 5 plus 6 by lambda. What was lambda? Minus 1. So I got minus 11. And then plug in lambda here. Lambda was minus 1. 2 plus 3 is 5. Okay, nice. Have you check out online who got that? Right, good job, Amanda. Good job, Sophie. Give a minus it? Yeah. Kaylin. What is that, Kaylin? Kaylin. Check it back. Okay. All right, nice job. Okay, so that's the way you handle questions like this, right? Let's do one more and then let's finish up with vector equation of a plane, right? I'll give you all the notes on that. Questions here? Huh? Yeah. So if you end up here where it's not consistent, right? Well, this one says it should intersect, right? That's that one that had 3 lines. For 1 second there. What was that past week, was it? Anyway, let's do this last one. And the question was to determine if they're skewed, right? But I'm not seeing it. But the same principle, right? That give it two lines and that's to determine if it's skewed or not. Ah, but based on what they asking here, because they have to show it in the side. But if they show it not parallel, if they show it skewed, yes, you have to show them all of them. Right, so the question said show it intersector. So it's supposed to intersect. All right. All right, so let's check it out fast. First thing first, for L1, right on y x, right, -1 -2, y is 1 plus alpha, and z is -2 plus, sorry, -2 -3 alpha. Then do the same thing for L2, x is equal to -2 plus beta, y is equal to 1 minus beta, and z -4 plus beta. Right? Next step, equate the x and the y. So that's -1 -2 alpha is -2 plus beta. So again, beta equal to 1 minus 2 alpha. Do the same thing here. 1 plus alpha is equal to 1 minus beta. 1 will cancel, so you'll get alpha is minus beta. So substitute 1 into 2, substitute 1 into 2, so you'll get 1 minus 2 alpha is equal to minus alpha. Okay? So when you carry it here, I got alpha to be 1. Look at that. Alpha to be 1, and beta will be -1. So for L1, you can find Z, right? That will be -2 -3. Alpha is 1, right? -2 -3 is -5. And for L2, plug in -1 here. -1 -5, right? Therefore, consistent, so they intersect. So they want the point of intersection, right? This will be the point. Z is -5. Solve for x. Plug in 1 here. -1 -2 is -3. Plug in 1 here. 1 plus 1 is 2. Look it up. So these lines are not skewed. These lines intersect. All right? Remember, if they don't intersect and they don't parallel, they are skewed. All right? Last thing you want to do today is the equation of a plane. Back to the equation of a plane. Ready? Last thing, back to the equation of a plane. All right. So so if you remember, right? If you remember, okay, that's to build up on what we were doing, right? When we started vectors, we looked at vector equation of point in 3 dimensions. Then we looked at a collection of points, and that gave us a line. Now we're looking at a collection of lines which give us a plane. Right? So we're trying to get the vector equation of a plane. So just like everything else, if we have a plane and you want to get the equation of the plane, we need a point on the plane and something that gives us direction. So we get a point on the plane and we get it something perpendicular to the plane. All right? Let's take a look at it. I will send you this note so you'll have it. How do we get the vector equation of the plane? Real simple proof. All right? If we have a plane and we have a perpendicular vector to the plane called n, if we have a point on the plane called A and some random point called R, we could use those pieces of information to get the equation of the plane. First thing first, we can draw A and R back to the origin. And we can find AR. AR is A to O plus OR. From a diagram, you can see that AO is minus A and OR is small r. All right? So now here's what we know. If we know a vector on the plane, that's a vector on the plane, right? AR. And we know that that vector is perpendicular to n. What we know about perpendicular vectors are, Divesh? Dot product is 0, right? If vectors are perpendicular, then we know that its dot product is 0. All right? That's it. Just multiply AR by n, and you'll see that here. Make it equal to 0, and you're good to go. Right? AR is minus A plus R by n. Multiply it out, and you get this equation here. Right? That equation is the vector equation of a plane. Okay? That is the vector equation of a plane. Right? I'll send in this note. For now, just make a note. R dot n is equal to A dot n. It's the vector equation of the plane. Don't write the whole thing, right? Or you can take a picture if you want, but I'll send it on the group. Right? Just do my favor, write down vector equation of the plane Rn is equal to An. Right? This is also called the scalar product form. Right? Don't write the whole thing now. Just write R by n is equal to A by n. N is the perpendicular vector, and A is the vector on the plane. Don't write the whole thing, let's try the last one. Right? So that's the vector equation of the plane. Right? And of course, we can take the vector equation of the plane and turn it into Cartesian. Right? This might look confusing, but it's just the variables, right? I'll show you with numbers how easy it is, right? So if you multiply x, y, z, which is r, by whatever n is, and then you multiply e by n, what you will get is something looking like this. And you'll get some scalar value here. Right? This is called a scalar product or a dot product, right? And you will get something looking like this. All right? Watch a small example here. If I give you a point on the plane, 2, 3, 2, 1, 3, and it's perpendicular, this is your A, and this is your N. You want to find the equation of the plane, right? All you're doing is you're multiplying R by N, A by N. And you end up with something looking like this. This here is the vector equation of the plane. To convert it to Cartesian, right? Just multiply x, y, z by that. And that's it. All right, so watch it again in case you get confused. This here is A, right, Shivish? This here is N, right? We're going to do A and N, Shivish. Very good, Shivish. Put it in this formula here. Okay, multiply E by N and you'll get 13. And then multiply R by this point and you will get the vector equation. If you want to go from vector equation, right, to Cartesian, multiply x, y, z by turn R into x, y, z. So multiply R, which is x, y, z, by this point here, which is 3 minus 2, 3, equal to B. All right? Okay, so I'm just going to give you one to try. We have time, we have 3 minutes. 3. 3. Our time pass. Right. Find the equation of the plane there. Do it fast. All right, let's back. What is the vector equation of the plane again? R by equal to. Right. As soon as Shivi's finished, we are all done. Divesh, what do you think, please? Tell me what's the answer there.
Yeah, it's the words.
T is what?
1 by 2.
But R is the variable. N is which one? Right? N is the perpendicular vector, and A is what? Point. That's it. Let's plug it in there. Actually, let's get the Cartesian one time. Come on, Shivi, wait, not you. All right, so you should have most of it already. R by N is here. That's 2, 4, 5. What A again, Shivish? What's E? Which is? Hey, stay quiet, huh? Well, and N is what again, Shivish? What's the value for N? Huh? Come on, what is it? Right, multiply 2 other time, how much you get? All right, 40. That's the vector That's the vector. I want the Cartesian one time. What do I do to get the Cartesian, Caleb? Caitlin? What do I do to get the Cartesian? So the vector is r by 2, 4, 5 is 40. What do I do? So you put r as x, y, right? Put r as x, y. That's it. Right? Multiply 2 by x, 4 by y, 5 by z. Make it equal to 40. That's it. You done?
That's right.
So that's vector what? That's vector equation. The playing Friday is online. Next week is no class. All right, online. So that's it for today. Right? That's kind of the end of